Hi everyone, today we're just learning about parallel lines. Okay, very interesting topic because most of the things are parallel, right? For example, this line here, these lines you see in this page are all parallel. Look at them. You have this line is parallel to that line. So what does this really mean? It means that parallel lines, they don't touch, right? Parallel don't meet, right? You can't have a situation where now you have this line and then you have this line. Okay, that's looks parallel. Yeah. See, these lines are not parallel, okay? But these ones are parallel. So these ones are not parallel, but these ones are parallel. Parallel don't meet. They're always gonna be they're always gonna be equal distance apart from each other throughout. So those are parallel lines. So you're going to study about parallel lines today and see how that works out and how that correlated to angles. Okay, so let's try and do that. So you have, let's say you have two parallel lines. Let's make them very big. Two parallel lines. Okay. You have this parallel line and you have another line here. And between these two lines, you have one line like this. Okay, and so what do we know about this? Is there's something called z angles. Okay, there's something called z angles in parallel lines. They call it z angles. So z angles, just write that up. Z angles, or they call it n shape angles, right? Or rather, the formal way of calling this, it's basically known as alternate angles. Alternative. Okay. So what you're gonna do is, when they say z angles, that means that these angles, they form z shape, right? For example, you might have an angle that forms z shape. So if you look at this, you see this is a z shape. So what does it mean? It means that this angle and this angle are equal. So alternate angles are equal. Basically, the theory says that alternate angles are equal, right? So meaning if this is x, then this will be x, right? So if this was, I don't know, 80 degrees, therefore this will be 80 degrees, and so on. So alternate angles are always going to be equal, right? They will look like z or n, right? I mean, you see that this looks like n. If you tilt your head a little bit, you see, oh, and it looks like capital letter N. Oh, it looks like Z. Okay, so let me give you an example of this problem. Let's say you have a problem says find the size of x, y, z, right? So we have two parallel lines. Two parallel lines, and this is A, this is B, this is E, this is F, C, D, this is X, this is Z, this is Y, and this is 74. That's the only thing I given. Okay, so now let's try and use the information that you have, alternate angles or z angles, and to calculate x, right? I mean, we still have to learn about other theorems on parallel lines to calculate y and z, but for this one, we're going to use the same example to calculate. You're going to use the same example to calculate using different theorems and parallel lines for another videos, 2 videos that I'm going to be making on parallel lines. Right, so bear with me here. So what do we know about parallel lines? We know that parallel lines, or about alternate angles, is we call them z angles, right? So we said they must form something that looks like z, and you see this look like z, and then we said this angle is equal to that angle. Okay, so already now we know that x is equal to 74 degrees. And what's the reason? The reason is because of alternate angles, right? So you don't have to write the whole name. You can say alternate angles, and everybody will understand who's doing maths. Okay, so yeah, that's the theory in alternate angles. Just check the other videos on corresponding angles and supplementary angles, and how we're gonna solve this problem using this theorem. Awesome.